Hello and welcome to this video on how to test indirect effects in the Mplus software. My name is Geiser, I'm an instructor with QuantFish. Many researchers test mediation models where they would like to find out whether indirect effects between variables are statistically significant. One effective and efficient way to test indirect effects is by means of path analysis. And one program that allows you to do that is Mplus. Mplus also has special options for testing indirect effects in the most effective way possible, meaning in a statistically powerful way by means of bootstrapping methods. And that's what I want to show you here in this video. You can see I have an Mplus syntax file open here for a simple mediation example for three variables, x, m, and y. X here is my exogenous variable, and I'm assuming that x predicts the mediator variable m, which in turn then predicts the outcome variable y. And so you can see that those three variables are in my names list, m, y, and x in this order, and that I specified my mediation model here in the model statement. Y on m means y is regressed on the mediator m, and then m on x means m is regressed on the exogenous variable x. Notice that in this case I did not include a direct effect from x to y. And so therefore this model will allow us to first of all test whether mediation is complete or whether we have full mediation. That could be one step in testing a mediation model, to leave out direct paths that are hypothesized to be zero in the population. And so in this case the idea here would be, the hypothesis would be that there's no direct effect from x to y, and as a result this path c prime is implicitly set to zero here in this model. And I'll show you how to test that hypothesis, that x does not directly affect y but only affects y indirectly through m, in a minute when we're going to take a look at the output for this model. Also notice that I included a model indirect subcommand here in the model statement where I typed y-index, and so that allows me to output all indirect effects from x to y. So if we have one or more mediators, then there will be indirect effects from x to y, and this model indirect command allows us to output those separately so that Mplus will calculate them for you, and then also will calculate standard errors for those indirect effects, as well as potential bootstrap results that it will provide in terms of confidence intervals. Furthermore, in the output command, I specified stdyx so that we can also take a look at the standardized solution, and I included the keyword C interval for confidence interval. Now, if you only include that keyword C interval, then Mplus will provide you with regular confidence intervals based on asymptotic standard errors. However, in this case, I also included the keyword BC bootstrap in parentheses behind C interval, and that refers to a bootstrap method, specifically bias corrected bootstrapping, which is recommended to test indirect effects. And so since indirect effects are given as the product of two or more regression or path coefficients, we want to test them ideally with asymmetric confidence intervals, because the product of two coefficients tends to be non-normally distributed, and therefore bias corrected bootstrapping is useful because it provides asymmetric confidence intervals that allow us to properly test indirect effects in a powerful way. Now, the BC bootstrap subcommand here works in conjunction with analysis bootstrap equals, and that command specifies the number of bootstrap samples. In this case, I chose to chose to use 1000 bootstrap samples for high precision of the bias corrected bootstrap results, and then the confidence intervals will be based on those 1000 bias corrected bootstrap samples. So let's run this input file and first of all take a look at whether we can reasonably assume that the direct effect from x to y is negligible or is 0 in the population. So I'm going to run this input file without the direct effect x to y first. So you can see the bootstrap samples are drawn, and that goes fast, doesn't take very long. When we scroll down, we can see that here we had 189 observations or individuals in this sample. We can also check that the number of bootstrap draws that we requested were completed, which here was the case. So all 1000 requested bootstrap samples were completed by Mplus, so there was no problem in any one of those. And then when we scroll down further, we can take a look at model fit statistics. Specifically, the chi-square test of model fit we should always look at. And you can see that here the chi-square test of model fit has a value of the test statistic of 19.446 with 1 degree of freedom. This model has 1 degree of freedom because there's one path that we're not estimating, and that's the path from x to y. The direct path or C prime path is not estimated, and as a result the model is over-identified with 1 degree of freedom. And you can see that the p-value for the chi-square statistic is very, very small, smaller than 0.0001, and so as a result the model is rejected. So the chi-square test indicates significant misfit of the model, and that is confirmed by other fit statistics that look really bad as well. So you can see the RMSEA is 0.312, so that is far away from an acceptable RMSEA. It should be 0.05 or below. And then also the CFI and TLI look bad. They should be above 0.95 for a good model, and here they are both of them are below 0.9. So that does not look good, and the SRMR is also really high at 0.09 or relatively high. It should be below 0.05 ideally, so it indicates that there's a significant residual here for that association between X and Y. So we can conclude from that there must be a direct effect also. When we fix the direct effect to 0, or when we don't estimate that effect, then the model does not fit well. So let's go back to our syntax and let's fix that, and let's estimate the path, also the direct effect from X to Y, because apparently this path is needed here. So I'm going to put that in by saying Y on X and M, so not just Y on M, but also Y on X. So putting this C prime path back into the model, and then all the other commands remain the same. And I'm going to save this and then run it again. You can see the bootstraps are drawn again, the bootstrap samples, and again here this worked just fine. When we scroll down, we can see that all 1000 requested bootstrap draws again were completed, so there was no problem there. And then when we go to the model fit section, we see now the model is saturated because we used up the only degree of freedom that we had in this path model to now estimate the third path as well between X and Y, and we had to do that because that model otherwise didn't fit. So here in this case we have to go with a saturated model. Now other path models may not be saturated. If you had, for example, more X variables, more M variables, more Y variables, then some of the direct paths may not be needed in the model, and then you may have an over-identified model. However, it should fit your data, otherwise the paths may be biased. So in this case we had to make the model saturated for it to fit, and that is fine. We can still interpret the parameter estimates even for a saturated model. So when we scroll down, we find the model results, and so those are all the direct effects. We have the path C prime from X to Y. So you can see that this path here is 0.281 in the unstandardized solution, and it has a standard error of 0.066 and a test statistic of 4.255. That's a Z statistic, and that Z statistic is significant at the 0.05 level, as shown by the two-tailed p-value here at the end, which is very small. So that shows you that this direct effect had to be in the model, and then previously when we omitted this direct effect, the model didn't fit, and that's because this path is significantly different from 0 as shown by the Z statistic here. So it was the right thing to do to include this path in the model. Furthermore, we see the Y on M path. So that's our B path, the path from the mediator to the outcome variable. And you see this path is also statistically significant. And so is the A path, which goes from X to M. So the X to M path here is also statistically significant. So then it does make sense under these circumstances to look at the indirect effect as well and test it for significance. When we scroll down further, we get the standardized parameter estimates as well. Here, in case you are interested in those are given under stdyx. And then we can scroll down further past the R squared for each outcome variable. We find a summary of the total indirect, specific indirect, and direct effects. And so this is useful because then you don't have to calculate these by hand, and also Mplus will provide us with tests of significance and confidence intervals. You can see the total effect here from X to Y is 0.453, and so that then includes the direct effect C prime plus the A times B indirect effect, because the total effect is the sum of the direct effect plus all indirect effects by definition. And so in this case, there's only one indirect effect because there's only one mediator. And so here the total effect then is C prime plus A times B, and that's 0.453. We also get the indirect effect here, so total indirect would be the sum of all indirect effects. In this case, there is only one, and that indirect effect is A times B, is 0.172. Now, we could look at the significance tests here to test the indirect effect at the end. However, a better method is to use the confidence interval, which is asymmetric and is based on the bias-corrected bootstrap, which we will see later. So that'll be provided further down in this output. You can see that then the specific indirect effects are also printed. In this case, it's the same number because there is only one indirect effect. So we get the same here under total indirect as we do for specific indirect. If you had more than one mediator, then you would get specific indirect 1, specific indirect 2, and so on for all mediators that you have in your model. And then the direct effect is also again provided. We already saw that. That's the C prime path that was previously shown in the output table already. You get the same thing for the standardized version of the model. stdyx is the version where all variables are in z-score metric. So same thing here is provided then for the standardized variables. And then below that are the confidence intervals. And that's really what we should be looking at for testing indirect effects. So when you are interested in finding out, is my mediated effect, my indirect effect statistically significant, then you should look at the confidence intervals in this section using the bias-corrected bootstrap like we did. And so here Mplus provides the point estimates in the middle, and this is actually for the model results. So we should scroll down further to go to the confidence intervals for the total indirect, specific indirect, and direct effects. And that's where we find the relevant results. We find the point estimates here in the middle under estimate. And so again, this is our indirect effect that we previously saw. A times B is 0.172. And so now to the right and to the left of this point estimate, we find the limits of the confidence intervals. First of all, in the columns lower 5% and upper 5%, we find the limits of a 10% confidence interval, because when you cut off 5% on each side, that is together, that gives us 10%. So this would be a 90% confidence interval, which is typically not of interest. We would typically go with a 95% confidence interval corresponding to an alpha or significance level of 5%, or we would go with a 99% confidence interval corresponding to an alpha level of 1%. And so we find the limits of a 95% confidence interval in the columns lower 2.5% and upper 2.5%. So in our situation, this would be the relevant values to look at. The lower limit of a 95% confidence interval for our indirect effect here are 0.093 to 0.253, so that's the upper limit, and you can see that this interval from 0.093 to 0.253 does not include 0. And that shows you that the indirect effect is statistically significant when your 95% confidence interval does not include 0, which here it doesn't. So you have a significant indirect effect. We can also take a look at the 99% confidence interval, for which the limits are given in the column lower 0.5% and upper 0.5%. And you can see that the 99% confidence interval ranges from 0.072 to 0.284. And again, that confidence interval also does not include 0. So this effect, the indirect effect in my example, would also be significant at the 1% alpha or significance level. Now, why again should you use a confidence interval to test the indirect effect rather than a simple p-value? The reason is that the product of two or more regression coefficients or path coefficients, which is the indirect effect, is not normally distributed, and as a result, asymmetric confidence intervals provide for a more powerful way of testing the indirect effect than would be a standard error and a simple test statistic. I hope you found this video useful to learn how to test indirect effects in the Mplus software. If you did, please subscribe to this channel. Check out the description for additional resources, including workshops, mediation and moderation that we offer through QuantFish, and I'll see you next time.